This is my school channel and my name is Abiola. For this video lesson, you are going to join me to walk through the topic binary operations. Okay, so we are going to look at the definition of binary operation. We are going to consider the operations, or you can refer to the properties involved in binary operations. As well, we are going to look at examples for us to better understand this concept. Do not go anywhere, stay with us, and we'll be right back. Welcome back to my school YouTube channel. Right here we are going to look through the topic binary operations. Alright, so we have the first slide right before us. We have this. Okay, binary operations and general properties. Okay, so let S, this should be set S, right, be a non-empty set. So being a non-empty set implies that there's at least an element in it, there's a member in it, at least one. Okay, and this asterisk sign is read as star. Okay, so and we have okay, let me read it together now. So we have let set S be a non-empty set and star be an operation on S, on set S. All right, so the operation on the set is a rule which assigns to each ordered pair of elements of the set a unique element of S. So what that means, basically, binary operation is just looking at a rule, right, that combines, a rule of combination, okay, regarding two elements. Okay, so we are looking at two elements in a particular set, right? So the rule of combination regarding those elements, that is what binary operation is actually talking about. So two elements, a certain rule that connects or make them interact, okay, with one another. So let's have the next slide. So we have some properties of binary operations. Okay, so some of them are listed here. We have the commutative property, we have the distributive property, we have the associative property, and we have the closure property. All right, so we have other operations that we're going to consider, you know, like the operators like your addition, your subtraction, your multiplication, your division, at least for basic arithmetics. So let's move on to the next slide. So this is just like a very good summary. Okay, so we have properties of whole numbers. So we are looking at this property under whole numbers. Okay, so you know we have whole numbers, we have real numbers, we have rational numbers, we have irrational numbers, we have integers, right? So we're just trying to consider these properties under whole numbers. So whole numbers we are looking at 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? Then natural numbers, we are going to start from positive integers, excluding 0, of course. So that is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's look at some of the properties just quickly. So we have the closure property. So we have if A, B, they're actually members, right, of whole numbers. So A falls to A or B, A and B falls to anything 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have A plus B. No, we are talking about whole numbers now, are actually members of whole numbers. So like for instance, let's take A to be 4, B to be 3. So 4 plus 3, that gives us what? 7. Do we see that now? Okay, so, but imagine that A is 3 and B is 4. So 3 plus 4, that gives us 7. So let's say A is 3 and B is 4. So we can see that under closure property, right, addition is a goal, right? So let's look at A minus B. So recall I said that A should be taken as 3 and B should be taken as 4. So 3 minus 4, that is minus 1. That is a negative integer. It is not a whole number. So do we see that? So the only exception to this is if this, right, is bigger than this. Okay, so that is, in general, subtraction is not applicable regarding closure property. We see that now. So multiplication is very applicable. You know, you can say 3 times 4, 4 times 3, you are still going to get whole number. So let's look at division. You know, for division right here, we are going to have 3 divided by 4, that is 0.75. Or 4 divided by 3, that is 1.5. Okay, so right here we're looking at whole number. So for closure property, you know, we can generally say that addition, multiplication, closed. Subtraction, division. Okay, so this is applicable when probably this, right, is a factor of this, or you can say this is a multiple of this. Okay, so that is where it's applicable. But generally, only this and this are go. We are good to go to put that way. So we have the commutative property. So look at commutative. Of course, we are looking at these elements are actually members of whole numbers. Okay, so look at this. So we've taken A to be 3 and B to be 4. Okay, so 3 plus 4 is actually the same thing as 4 plus 3. You are still going to get 7. Do we see that now? So that means here, under commutative property, order is immaterial. So no matter how you order your elements that are undergoing the operations, right? So it doesn't affect your answer. You still get the same answer. So we have A minus B, you can see, is not equals to B minus A. So under commutative property, if you look at this closely, so 3 minus 4 is not the same thing as 4 minus 3. Do we see that now? So under commutative, subtraction is in. Let's look at multiplication. 3 times 4 is the same thing as 4 times 3. You're still going to get 12. So let's look at this. 3 divided by 4 is not the same thing as 4 divided by 3. 3 divided by 4, that is 0.75. 4 divided by 3, that should give you 1.333 thereabouts. So we have associative property. Okay, look at this closely. So we have A, B, C, okay, members. This means members of set W, and W represents all numbers. Okay, so look at this. So this is where we actually rearrange your parentheses. And when you rearrange the parentheses, alongside the operators, you are still going to get the same answer. So that is where associative property comes in. So look at this. So we've taken A to be 3, B to be 4, C, let's say to be 5. Okay, so let's make that happen. So this is 4 plus 5, that is 9. Right? 9 plus 3, that is 12. So let's check if it's actually applicable, right? When you rearrange your parentheses. Okay, so we have, this is 3 plus 4, that is 7, right? 7 plus 5, that gives us 12. All right, so look at this. 4 plus 5, that is 9. 9 plus 3, that is 12. So we get 12. So addition under associative property is a go. Okay, so let's look at this. So remember we said 3, 4, 5. So 4 minus 5, that is minus 1, right? So we have 3 minus 1, that is 4. Okay, so let's check for the other side. Okay, so we have 3 minus 4, that is a minus 1. So minus 1 minus 5, that is minus 6. So we can see that it's not applicable. So basically, if you try out the same thing, right, with the other operators, you will get a definite expression regarding this. So for associative property, addition and multiplication, right, they are good to go. Okay, generally. So we have distributive property. So we have, under distributive property, you're not just considering 2 binary operations alone, right? You are looking at 2 different binary operators, right? So it can be the star and the inverted triangle. Okay, so let's look at this. So you can see right there what this is telling us in summary. I'm going to explain this as we move further in the video. What this is telling us is that multiplication, right, is distributive over addition and is also distributive over subtraction, but not vice versa. So join me as we proceed to the next slide. So binary operation properties. Okay, so we have this note. So let this be a binary operation defined on the set A. So remember that the set should not be an empty set. At least we are talking about a member. But binary, we're talking about at least 2 members for us to be able to run our confirmation. So at first, we are going to consider the closure property. So the closure property is just telling you that, okay, for all of x and y, x, y, they're actually members of set A. Okay, so look at this expression. So that is the rule of combination, whatever rule of combination you are going to give to x and y, right? They are going to produce another member, okay, that should be a member of this set. Okay, so basically now, let's say the closure property for this we are looking at should be, let's say set A is talking about whole numbers, and we have taken x to be 3 and y should be 4. So let's say that this operation is about, let's say something like this. Okay, I think we have examples on our next slide that we can work with. So let's move on to the next slide. Good, so we have closure property formula. So A plus B, right, still give us real number. R should stand for real number. So A minus B, this. Okay, just take note of that, A times B. Because remember we've taken A to be 3 and B to be 4. So 3 minus 4, Okay, so we've taken this R. Let's say this R, we are talking about whole numbers from what we have been using. You should know that normally in sets or in arithmetics, when you say R actually implies real numbers. Okay, let's just take it as whole numbers. So for whole numbers, look at this. We have A plus B. Okay, that's 3 plus 4, that gives us 7. That's a whole number. Look at this. 3 minus 4, that gives us minus 1. Minus 1 is not an whole number, it's a negative integer. So you can say it's not applicable. So we have 3 times 4, that is 12. Good. We have 3 divided by 4, that is 0.75. So that is not applicable. So generally, like I mentioned earlier, multiplication and addition, they are good to go for closure property. But subtraction and division, right, they are not. Except for, the exceptions include, if it's subtraction, then this bigger one comes before this. So I'm going to have 4 minus 3, that will give me 1. Then this will now be probably a multiple of this, or this will be a factor of this. Okay, so that should be how this thing works. So let's move on to the next slide. Okay, so we have associative property of multiplication and addition. So recall that we stated generally, right, regarding the operators. So we are looking at associative property around addition and subtraction. So remember that we mentioned that associative property actually talks about you reordering your parentheses and getting equivalence. Okay, so the answer you are going to get when you arranged your parentheses and when the parentheses was in its original form should be the same thing. Okay, so let's look at the multiplication, right? Multiplication in associative property. So look at this. We have A and B in the parentheses, then we have C outside. So let's rearrange it. This time around, we now have B and C inside and A is outside. So let's try that out. So 3 times 4, that is 12. 12 times 5, that is 60. So let's run a confirmation. We have 4 times 5, that is 20. 20 times 3, that is 60. So we can see multiplication is good to go for associative property. So let's look at addition as well. So we have 3 plus 4, that is 7. Then we have the one outside. So 7 plus 5, that is 12. Okay, let's run a confirmation again. We have 4 plus 5, that is 9. 9 plus 3, that is 12. Let's check the next slide. So still on the associative property. So look at this. When you can group the numbers in any combination. So you can see that now. So even if I decide to take A plus C, then I send B outside, I should still get the same thing, right, in the flip side. So look at this. So we've taken B and C as 5 and 3, then A as. So look at this. 5 plus 3, that is 8, plus 2, that is 10. 2 plus 5, that is 7, plus 3, that is 10. Right, so if I even decide to do 2 plus 3, then 5 is outside. 2 plus 3, that is 5, plus 5, that is 10. So the same thing happens to multiplication. So when you multiply, you can group the numbers in any combination, and you should still get equivalence. So let's move on to the next slide. So we have the distributive property of multiplication. Okay, so like I mentioned earlier, multiplication is distributed over addition and subtraction, but not vice versa. Okay, so look at this. So I have A, right, B plus C. So that means you are working with what you have in your parentheses first, then A multiplies it. Okay, so recall I've taken A as 3, right, B as 4, then C as 5. Okay, so let's make this happen together. So we have B plus C, that's actually, okay, let's do this. So I have 4 plus 5, then I have 3 outside. Let's see if it's the same thing. Then when we make A to interact with them, okay, we are distributing it now. So I have A times B, that is 3 times 4, that is 12, right, plus A times C, that is 3 times 5, that is 15. What do I have? I have 27. So let's see if that is correct. 4 times 5, that is 9. 4 plus 5, that is 9. 9 times 3, that is 27. So you can see multiplication is distributive over addition. Let's run a confirmation as well for subtraction. So I have right here, I have B minus C, that is 4 minus 5, right? That is minus 1. So minus 1 times 3, I have minus 3, okay? So that's the confirmation for this side. So let's run the confirmation here as well. So I have AB, that is A times B, that's 3 times 4, that is 12, right? Minus, okay, A times C, that is 3 times 5, that is 15. 12 minus 5, that is of course minus 3. So we've gotten our confirmation. That's distributive property, okay, for multiplication, you know, is distributive over addition and subtraction and not vice versa. Okay, so I've prepared examples in this video as we go further. So let's move on to the next slide. distributive properties still. So this is another example. So what is the answer to this? Okay, so you can see we're just trying to run a confirmation, just like what we did earlier. So the 2 outside the bracket is multiplied onto everything that is inside the bracket. So we are trying to distribute multiplication over addition. So I have 2 times 4, that is 8, right? 2 times 3, that is 6. 8 plus 6, that is 16. Or you can try it like this. 4 plus 3, that is 7, times 2, that is still 14, right? So let's move on to the next slide. So we have the identity property. So look at this. The identity element, all right, or the neutral element. Okay, so look at this. So when you are adding a particular member or element to the identity element, you should still get back your element. Even when you subtract from it, you should get back that same element, right? So this is what we have here. So when it comes to multiplication, when you multiply that same element by 1, right, you should get back your element. That same element by 1, you should get back. So for additive, you should have your 0. Then for multiplication, it should be 1, right? So let's do some confirmations together. Let's move on to the next slide. So we have additive identity and multiplicative identity. So at first, look at this. This is used for addition operations. So look at this. Given this, so this is a member or an element or a number, so we have a value. So we have p plus 0 is the same thing as 0 plus p should give you p, right? So basically, if you are taking p to be 3, right? So 3 plus 0 should be the same thing as 0 plus 3 and should still give you 3. So whatever the input is, right, it should be able to, under additive property, should be able to give you that same number back, okay, and that is usually 0. Okay, so look at this. So we have 0 is the identity element. Okay, so look at this. For example, 77 plus 0 gives you 77, right? So minus 77 plus 0 still gives you minus 77. So identity element is actually the element that is like going to produce the exact copy of that element that you are combining with it. All right, so if it is addition, usually that should be 0. Then if it is multiplication, you're looking at 1. All right, so let's look at our multiplicative identity. So it is used for multiplication operation or the operator. So look at this. P times 1, that is still P. Or you can say 1 times P if you decide to change the order, you know. So that is, so 1 is the identity element. So for example, 77 times 1 should give you 77. Minus 77 times 1 should still give you minus 77. So you can just call the identity element or the neutral element as a screenshot, right, of that particular element. Okay, so it's just an element that is just going to be there, right? When you now combine this to that identity element, you still get this back, right? So it's just like you throw in, yeah, exactly. So just like you throw in a stone, right, into a bucket of water. Okay, at the end of the day, you are still going to get your stone back, right? It doesn't turn to something else. Okay, so let's move on to the next slide. So we have some examples just to buttress our properties. Okay, so we have inverse property. So basically in inverse property, you know, you are looking at that property whereby, you know, when you multiply it. Okay, let me use this to explain it. So look at this. I have a plus minus a, okay, should still be the same thing as minus a plus a should give you 0. This is the element here. This is its inverse. All right, so for addition, you are looking at that particular value, right, that you will combine with the original element, right, that is going to give you an identity element, and that is 0. Okay, so it's just like saying you are adding that element to its opposite, right? Opposite of 1 plus 1 is minus 1. Opposite of minus 1 is plus 1. Do you see that now? Opposite of plus 2 is minus 2. So under additive property, so look at this. So 5 plus minus 5, or you can say minus 5 plus 5 will still give you 0. So inverse property, you're actually talking about that particular value that you will add to a particular element, right, that will give you an identity element. Okay, so look at inverse property of multiplication. So that is, you are basically saying that it will just be the combination between the original element, right, times 1 over the element itself. Okay, so look at this. So we have 5. So the multiplicative inverse of 5 is actually 1 over 5. So if it is 6, it will be 1 over 6. If it is 12, it's going to be 1 over 12. If it is 1, it's going to be 1 over 1. Do we see that now? So given that, or provided that the elements you are working around with is not actually 0, because this will come out as undefined. Do we see that now? So let's move on to the next slide. Yes. So the additive inverse property tells us to simply take a number and add its opposite so we get 0. All right, so 0 now is the identity. Okay, so look at example 1. So the opposite of plus 6 is actually minus 6. So you are owing somebody 6 naira. You have 6 naira on you rather. So you are owing somebody 6 naira. If you pay the 6 naira, what do you have left? Is 0. No debt, no balance. So that is what we are looking at. So minus 6 is the additive inverse of 6. All right, so that is how we explain inverse property. So let's move on to the multiplicative aspects of inverse property. Okay, so what is the multiplicative inverse of 15? Right, so 15 times what will give you an identity result or identity element. Right, that will be 15 times its own inverse. So that will be 1 over 15. So the multiplicative inverse of a number is that number, right, as the denominator. So the multiplicative inverse of 15 is 15 as the denominator and 1 as the numerator. Do we see that now? So provided that this 15 or the value that used to be here is not 0. Okay, so that will come out as undefined. So that is how we go about it. Let's move on to the next slide. So this is just a summary of all the concepts that we've examined so far. So we have property, so we have the addition operator and the multiplicative operator as well. So under closure, we know we have a plus b is a real number, right? So under closure, addition is good to go. Multiplication as well is good to go, right? It's going to give you a real number. Look at commutative. Commutative, that means no matter how you arrange, order doesn't matter. So a plus b should still give you b plus a. The same thing, a times b should give you b times a. We see that now. So, but it's not usually applicable. It's not generally applicable to subtraction and division under certain conditions if it's going to work. I mentioned that earlier. So we have associative. So look at this. We are rearranging your parentheses. So a plus b plus c should do the same thing. The same thing goes for multiplication. Then identity, right? Identity is just that particular value, right, that you had to a particular element, and you still get that element back. That's under addition, right? Then for multiplication, that particular value you used to multiply that element, and you still get the same element back. Okay, so that's what we have right here. So look at this. So it's just like you adding salt to rice. Okay, you are cooking rice, then you go ahead to add salt. Okay, I think that's very, very good. So at the end of the day, you are going to notice that you are going to have a salty rice, right? But from your observation, you won't see the salt because it's going to dissolve, right, in the whole cooking setup, right? So basically now, that salt now is the identity element, right? So it doesn't make a difference, a physical observable difference, right, in the value of the element. So we have it here, we have it here. So it's good to go for addition and multiplication. Then we have inverse. So inverse is just the opposite, right? That will give you an identity element. So remember that the identity of this is actually 0 because a plus 0 will give us a. Again, so identity of this is, you can see it will give us this back. Then we have distributive, when you take this all over this. So this is, of course, a multiplicative distribution over addition. Okay, so this is the end of today's lesson, but you know that there is more to come. All you just need to do to have access to this full video lesson is to kindly subscribe. So just click on the link in the description below. This is going to take you to the My School website. Right there you get to subscribe for the video lessons and you have access to this particular full content and other mathematical videos as well. So do not forget that you have to hit the like button. Also, use the subscribe button and always tap on bell notification for you to get alert immediately we upload the next video content just for you.